Almost 5 minutes are over. Okay. Anyway, we will start. Let me present my screen. Is my screen is visible?
Yes, sir.
Yes, sir.
Okay. Uh, Let me review in the last lecture what we have discussed, and we will continue again. So what we have discussed in the last lecture? Uh, what we have discussed? I think we have discussed about the definition of rectangular window. Hope you all have noted this. Have you noted
Yes,
this?
sir.
Definition of rectangular window. Then its graphical representation. Then after that its spectrum function. Then this frequency response for the window function we have seen. Right. So this is the frequency response of window function at n equals to 25, and the frequency response, that is magnitude response of window function at n equals to 25, and this is at n equals to 51 and n equals to 51 magnitude response. If you compare this frequency response and the magnitude response, as the value of n increases, the main lobe is getting reduced, and the side lobes are also getting smaller and smaller, right? And here the attenuation is also getting increased, that is increased it is. Okay, so these are some of the points we are noted after the graph. The frequency response is real and its zero occur when nw by 2 equals to k pi, where k is an integer, or the response of omega between 2 pi by n and minus 2 pi by n is called the main lobe. The other lobes are known as side lobes, as already I told you. As the window is made longer, the main lobe becomes narrower and higher, and side lobe becomes more concentrated around omega equals to 0. The main lobe width for rectangular width is, that is rectangular window, not width, rectangular window is equal to 4 pi by n. The higher side lobe level is equal to approximately 22% of the lobe amplitude, or minus 13 dB, alternative to maximum value at omega equals to 0. So these are the points we are noted from the above graph. Now suppose what we are doing in the
Excuse
next
me,
part.
sir.
Yes.
We have just drawn the graph, sir. We haven't wrote this point.
Okay, you have not noted these points. Okay. You just note down this about the graph, like what I told, you just note down these points so that it will be helpful for you. Are you noting this?
Yes, sir.
Yeah, please. or just make this correction also. This is rectangular window. Width of rectangular window, you just write is width of rectangular window. Or hello,
Wait, sir.
or can I dictate it? होता है क्या आज?
हाँ sir, done.
Okay.
Did sir.
Still I need to wait. So any confusion in these points? कळतंय का point? What the point I have written here? Any questions you are having? Shall I move to the next part?
Yes, sir.
Okay. Now, as we all know that to get a finite impulse response filter, what we are doing? We are multiplying this HD of n with a rectangular window, as already we have seen the procedure. So h of n equals to HD of n multiplied with the window, that is omega r of gain. Then the frequency response of the truncated filter can be obtained by periodic convolution. Means what? So this is what the periodic convolution we are having. Okay, so this is what the periodic convolution, as I already told you that if you take a convolution of this response of the filter and the window, so that is HD of e power j omega is convoluted with omega of e power j omega, then we will get this kind of frequency response, right? So this is what the frequency response of a low pass filter, and this is the magnitude frequency response of the low pass filter. Okay, So here again, as we are observing the ripples which are present in the pass band as well as the stop band at n equals to 25. And here magnitude response is having, this is a constant value up to the cutoff frequency, and then there is a ripples which are present in the stop band again, right? And the attenuations here is like minus 20 we are getting as a attenuation for the frequency response of the rectangular window at n equals to 25. Okay, so already we have solved the example on this. Hope you are understanding this graph. Any difficulty here? Hello, am I audible?
No, sir.
Not audible? ऐकू येत नाही का?
येत आहे सर.
मग कोणाला ऐकू येत नाही आता? Right? You just note down these points. खोबरे
Yes, sir.
ऐकू येत नाही?
ऐकू येते सर. तुम्ही अंडरस्टूड म्हणला ना ते.
Okay, काय अंडरस्टूड झालं सांगा मला. So this graph you are talking?
हा सर.
Okay, so we have seen the procedure of designing and filter, right? तो वहां पे हमने क्या किए थे? So HDFN कैलकुलेट किए, बराबर? Yes or no?
हाँ सर.
HDFN कैलकुलेट करने के बाद उसको ट्रंकेट करने के लिए क्या किए थे हमने? What we have done to make it as a truncation? We have written h of n equals to hd of n for magnitude n less than or equals to n minus 1 by 2. इनफाइनाइट सीक्वेंस को फाइनाइट सीक्वेंस में कन्वर्ट कर रहे हैं, बराबर?
हाँ सर.
उसके बाद क्या किए? So here in this window function, instead of simply h of n, I have taken it as omega r of n also. मतलब ये दोनों फंक्शन मल्टीप्लाई कर रहे हैं यहाँ पे. If I take its convolution, तो उसके बाद हमें क्या मिलेगा? फ्रीक्वेंसी रिस्पॉन्स वी आर गेटिंग. सो दैट मीन्स वी आर गेटिंग दिस एज अ फ्रीक्वेंसी रिस्पॉन्स. तो ये फ्रीक्वेंसी रिस्पॉन्स फॉर्मूला है, राइट? सो एच डी एफ ई पावर जे ओमेगा इज कन्वोल्यूटेड विथ ओमेगा ऑफ ई पावर जे ओमेगा. दिस एच डी एफ ई पावर जे ओमेगा इज अ रेस्पॉन्स फॉर एच डी एफ एन एंड ओमेगा ऑफ ई पावर जे ओमेगा इज रेस्पॉन्स फॉर ओमेगा आर ऑफ एन. ठीक है? Then finally if you are plotting its response, हम बाद में क्या कर रहे हैं? We are creating one table. Then again we are varying the value of omega from 0 to pi. किए क्या नहीं? हेलो हेलो
हाँ. यस सर.
देन उसके बाद क्या किया हमने? कैन यू टेल मी नाउ? टेबल के बाद क्या किया हमने? हेलो, what we have done after the table? To plotting a table of omega value, frequency, ग्राफ प्लॉट किए. तो वही यहाँ पे दिखा रहा हूं मैं आपको. ये जो ग्राफ है आपका लो पास फिल्टर फ्रीक्वेंसी रिस्पांस का प्लॉट है, और हमने जो प्लॉट किए थे वो मैग्नीट्यूड रिस्पांस प्लॉट किए थे. ठीक है? तो मैग्नीट्यूड रिस्पांस जब प्लॉट करेंगे आप, इट विल लुक लाइक दिस वे. हमने क्या, लाइक वी हैव कैलकुलेटेड अप टू n इक्वल्स टू 9 और 11 समथिंग वी हैव कैलकुलेटेड. लेकिन आपका जैसे जैसे n का वैल्यू बढ़ते जाएगा, देन वी विल फाइंड अ ग्राफ्स लाइक दिस. So this is what the frequency response of in amplitude and then again in magnitude form we are writing. ठीक है?
हाँ sir, understood.
Okay, thank you. Now, so this is what all the things we have written here. What we have written is the desired response of low pass filter changes abruptly from pass band to stop band, but the frequency response changes slowly. ठीक है. This region of gradual change is called filter transition region. As already we have discussed all these points, which is due to the convolution of desired response with the window response main lobe. The width of the transition regions depend on width of the main lobe. Then again, as the filter length increases, the main lobe become narrower, decreasing the width of the transition region. The convolution of the desired response and the window response side lobes give rise to give rise to the value of here ripples in the both pass band and the stop band. The length n will not reduce the ripples but increase its frequency. So here points we can observe from this above graph. Okay. You want to note down these points or you will note down it by your own? Are you expecting to note down these points? तो ऑलरेडी
Yes, sir.
बताए सही है, इसमें कुछ ज्यादा नया चेंज नहीं है. Anyway, if you want to note down, you just note down this, so that it will helpful for you again while reading. You can remember the things. Note down this, no problem. or
Wait, sir.
finished?
Yes, sir.
So what you are understanding with this? Can anyone tell me? क्या समझ में आ रहा है ये पॉइंट से आप लोगों को? Yes, anybody? What you are understanding with this? Can I get any answer? 1%, 2%, 5%, 10%. If anything you have understood from this, please tell me. Hello? Am I audible?
Yes, sir.
Please give me some answer. What you understood with this? What is the first point is telling? Can anyone read it?
Response
Hello?
of a low pass filter changes abruptly from pass band to stop band, but the frequency response changes slowly.
What does it mean? The desired response is like a theoretical value we can say. मतलब theoretical और ideal case में क्या होता है low pass filter के लिए? What will happen in ideal case for low pass filter? There is a sudden change. बराबर suddenly zero पे आ जाता है वहां पे. But the frequency response suddenly zero पे आता है क्या वहां पे? आता है
No.
क्या? Practically आता है क्या वहां पे? No. तो slowly change होता है वहां पे. So that is the meaning of first point. What about second point? Yes. What is second point? Can anyone read it?
This
Can
region of
anyone read
gradual
that?
change is called this region of gradual change is called filter transition region, which is due to the convolution of the
हाँ
desired response with the window response main loop.
हाँ, क्या मतलब है इसका अभी? जो ट्रांजिशन बैंड है अपना, ट्रांजिशन बैंड जो बोल रहे हैं ना हमें अभी, लाइक आफ्टर पास बैंड द सिग्नल इज मूविंग टुवर्ड्स द स्टॉप बैंड, वहां पे जो स्लो प्रोसेस हो रहा है वहां पे, तो उसको हम ट्रांजिशन बैंड बोल रहे हैं, राइट? द ट्रांजिशन बैंड is getting due to the convolution of desired response with the window response function, जो हमने ग्राफिकल रिप्रेजेंटेशन में देखे हैं अभी, राइट? तो ये वैल्यू देखे हमने, लाइक इफ आई कन्वॉल्व दीज टू यहाँ पे, राइट? ये अभी आपका क्या है? सो दिस इज द फ्रीक्वेंसी रेस्पॉन्स ऑफ द विंडो एंड दिस इज, क्या बोल रहे हैं हम यहाँ पे, लाइक दिस इज व्हाट द कन्वोल्यूशन ऑपरेशन, लाइक इफ यू टेक the convolution of this HDF e power j omega convoluted with omega f e power j omega, and that reason we are calling it as the transition region or the transition band, we can call normally it is. Okay, the next क्या बोल रहे हैं हम यहाँ पे? The width of the transition region depends upon the width of the main lobe. मतलब क्या है अभी? Suppose if you look at into this, ये जो main lobe दिख रहा है आपको, right? So this is what the main lobe we are calling here. So this part as the main lobe. This is for n equals to 25 and this is for n equals to 51 again. So आपका width of the transition band is depending upon this main lobe again. So that is its meaning. And next, as the filter length increases, the main lobe becomes narrower. If you just seen in the figure that n equals to 25 है तो आपका width बड़ा है, और n equals to 51 है तो width small होते जा रहा है. Getting my point? Yes or no?
Yes, sir.
Hello? Then the convolution of the desired response and the window response side lobes give rise to the ripple in both pass band and stop band. So that is what we have seen in the frequency response graph. So यहाँ पे this is how the length n will not reduce the ripples but increase its frequency. That means as the frequency increases, means what is happening here? The length का n value अगर बढ़ रहा है तो frequency increase होते जा रहा है. So that we can see from this graph also. यहाँ पे ये जो ग्राफ है अभी, लाइक हियर इफ यू लुक एट इनटू दिस पार्ट, तो यहाँ पे देखो अभी, तो हियर n इज इक्वल टू 25 एंड हियर n इज 51, तो फ्रीक्वेंसी का वैल्यू बढ़ते जा रहा है यहाँ पे. सो दैट इज व्हाट्स इट्स इंडिकेशन. सो दिस इज ऑल अबाउट द रेक्टेंगुलर विंडो. होप यू अंडरस्टूड नाउ. स्टिल एनी कंफ्यूजन? यस और नो?
Yes, sir.
What about others? Still any confusion you are having? Hello? आहेत का तिथे कोणी दुसरे?
No, sir.
No, sir, no confusion.
क्या? Okay, thank you. Let me move to the next part. Then the triangular or Bartlett window. This is not for your syllabus, but just for your knowledge, I will just go through those parts. So here this triangular or Bartlett window is just defined like omega t of n equals to 1 minus 2 magnitude n divided by n minus 1 for n minus 1 by 2 less than or equals to n, less than or equals to n minus 1 by 2. And its response is like this. So triangular window दिखता है कैसा है आपका? As the name it is indicating, how the graph will look like. ग्राफ कैसा एक्सपेक्टेड है अभी यहाँ पे? Anybody?
Triangle.
Triangle it is. Okay. Discrete or continuous? Discrete or continuous?
Discrete.
discrete it is, because we are representing it with the n value, so it will look like this, right? So n equals 25 अगर आप ले रहे तो आपका ग्राफ ऐसा दिखेगा, right? Then again we are plotting its frequency response, n equals 25, n equals to 51. तो ये frequency response अगर आप for a window we are plotting first, तो क्या ऑब्जर्व हो रहा है यहाँ पे? If you look at into this graph and the previous graph of rectangular window, can you tell me the change? क्या चेंज हो रहा? n equals to 25 rectangular window graph and this triangular window graph. What is the change you are observing? Yes, anybody? काय चेंज दिसतंय तुम्हाला तिथं? You just check your graph, what you have noted with this.
Side loop.
What is the change you are observing? Yes? Someone is speaking?
Side loops.
बोला ना. Side lobes are reduced 1 point. ठीक है, मतलब रिपल्स बहुत कम हो गए यहाँ पे. What else again? और क्या चेंज दिख रहा है आपको? यस, और क्या चेंज दिख रहा है? ऑब्जर्वेशन इज रिक्वायर्ड. What is the further change? काय चेंज दिसतंय का नाही? हेलो, हेलो,
Yes, sir. Main loop.
मेन लोब क्या चेंज हो रहा है? मेन लोब का व्हाट इज द विड्थ ऑफ मेन लोब इन रेक्टेंगुलर विंडो?
4 pi by n.
विड्थ ऑफ मेन लोब इन रेक्टेंगुलर विंडो इज 4 पाई बाई n, बराबर. तो यहां पे अभी इसका विड्थ बढ़ रहा है, सो इट इज 8 पाई बाई n. गेटिंग माई पॉइंट? तो मेन लोब बढ़ रहा है और साइड लोब घट रहे हैं यहाँ पे. सो विद दैट what we are getting is we are getting the less attenuation. तो वहां पे -13 dB था अपना attenuation और यहाँ पे -25 dB है, राइट? तो वो कम होते जा रहा है वैल्यू. सो दैट इज द डिफरेंस वी आर ऑब्जर्विंग. अगेन इफ यू मूव टू द n इक्वल्स टू 51, क्या हो रहा है यहाँ पे? व्हाट्स हैपनिंग हियर अगेन? Yes, can anyone speak on this? What difference you are observing? Hello? What is the difference you are observing? Hello? Are you able to see screen my voice?
Yes,
Yes,
sir.
sir.
मग काय तर आवाज द्या रे बाबा. नो लाईक येस म्हणा, नो म्हणा, स्पीक समथिंग. If I am asking you something, sitting idle is not the solution for all the things. क्या डिफरेंस पता चल रहा है दोनों ग्राफ में? अभी दिसतंय ना डिफरन्स काहीतरी तिथं?
Again, it reduced main loop and side loop.
Okay, again the side lobes are almost near to zero value, right? And the main lobe is narrower as compared to this n equals to 25 again. So this is all about the rectangular window. तो ये सब ये देखो, अभी ये अगर फ्रीक्वेंसी रिस्पांस का ग्राफ देखेंगे, हमने लो फ्रीक्वेंसी रिस्पांस ग्राफ ऑफ रेक्टेंगुलर विंडो भी देखे और ये ट्रायंगुलर विंडो का भी देख रहे हैं अभी. कैसा दिख रहा है? हाउ द डिफरेंस इज ऑब्जर्व्ड? सो ऑलमोस्ट रिपल्स आर जीरो ईयर, मतलब रिपल्स नहीं है यहाँ पे, राइट? लेकिन ट्रांजिशन बैंड बढ़ रहा है आपका क्योंकि मेन लोब का विड्थ बढ़ रहा है. सो दैट इज अ ड्रॉबैक विद दिस पार्ट अगेन. देन अगेन इफ आई मूव टू द नेक्स्ट पार्ट, लेट्स टेक हैनिंग विंडो. लेकिन आप लोगों को हैमिंग विंडो है ना, इट्स नॉट लाइक हैनिंग विंडो. उस दोनों में ज्यादा डिफरेंस नहीं है. देन वी विल मूव टुवर्ड्स द हैनिंग विंडो पार्ट. यस, दिस इज द हैमिंग विंडो. ओके, सो हियर हैनिंग एंड हैमिंग आर द ऑथर्स अगेन, लाइक ऐसा कुछ ये नहीं है सेपरेट. सो दे हैव गिवन जस्ट मॉडिफिकेशन इन द given windows, that is triangular window and rectangular window are standard windows. So for them they have just given the window modification with the formula. You just write down this Hamming window, you just write the title, but you just write down the mathematical formula of that. And also you just write down the frequency response of Hamming window formula. Just note this formula. अभी इक्वेशन ये मतलब ये लिखना पड़ेगा आपको, राइट? यू नीड राइट दिस एज इक्वेशन ये. Have you written the title Hamming window? Hello?
Yes, sir.
Title you have written, na? You just write down this equation A first. So that is generalized equation. Don't write that above wording part. Just write omega alpha of n equals to alpha plus 1 minus alpha cos 2 pi n divided by n minus 1 for the value minus n minus 1 by 2 less than or equals to n less than or equals to n minus 1 by 2. Call it as equation A. Call it as equation A. यहाँ पे सिर्फ if you put alpha equals to 0.5, that window we are calling it as Hamming window. Just write 1 point. For alpha equals to 0.5, the above equation can be used for Hamming window. H-A-N-N-I-N-G. If I put alpha equals to 0.5, the above equation is called as Hamming window. Or
Yes, sir.
Yes, sir.
the next line you just write. You put alpha equals to 0.54. Put alpha equals to 0.54 in equation A. Alpha equals to 0.54 in equation A is called Hamming window. Is called Hamming window. Just note down this. Hope it is visible to you all.
Yes,
दिख
sir.
रहा है ना सबको? Okay, please note down that. Here WH of n stands for, H stands for Hamming window again. You need to just remember these formulas while solving the examples again. Or have you finished?
Yes, sir.
Okay. Now let's move again. Further, this is what the diagram, how it looks like. An above equation, then you will get the graph like this. Just note down this graph. ट्रायंगुलर विंडो को ही थोड़ा मॉडिफाई किए. It's looking like the curve now, curve structure. Or
Yes,
finished?
yes, sir.
Yes.
Okay. Now let's move again further. Like what you are observing? क्या difference है अभी यहाँ पे? If you compare these graph into the previous graphs, so what difference you are observing? Here almost ripples are completely zero, and the width is remaining as again same like 8 pi by n for n equals to 25, and again it is narrower to n equals to 51, but wherein the attenuation value is reduced drastically, that is like minus 41 value we are getting as attenuation value. ठीक है? Just note these graphs. So any difficulty here again in understanding this graph? Or shall I move next part?
Yes, sir.
Okay. Now let's move the next part. This is how the graphs we have noted for window function. So what is the observation we have done here? The window sequence and its magnitude response are shown in the above figures. The peak side lobe level is down about 41 dB, that is minus 41 dB from the main lobe peak, an improvement of 10 dB relative to the Hamming window. So this point, if you want to just last point, you just note down. The peak side lobe level is down about 41 dB. Down matlab negative value आ रहा है यहाँ पे. From main lobe peak, this is the main difference with Hamming window and the Hamming window. An improvement of 10 dB relative to the Hamming window. Just note down that one point. The peak side lobe level is down about 41 dB from the main lobe peak, an improvement of 10 dB relative to the Hamming window. Or
Yes, sir.
Yes, sir.
okay. Now, so this is how the final graphs looks like. So how the first to 25 and the magnitude response of low pass filter using n equals to 25. Just note down this frequency response. And we are going to do the experiments on this, like using MATLAB. We are plotting these graphs. So there you can understand very easily again, like If you take like 100 samples, then you can plot the graphs very easily. We are going to write the MATLAB code for this to understand these graphs, how we are getting again. So that practical experience also we can have on this part. Or have you finished?
Yes, sir.
Okay, what difference you are observing here is the peak of minus 53 dB, an improvement of 9 dB with respect to the Hamming window filter. However, at higher frequencies, the stop band attenuation is low when compared to that of Hamming window. And lastly, we can write Hamming window generates lesser oscillation in side lobes than the Hamming window for the same main lobe. मेन लोब का विड्थ दोनों का सेम है, फिर भी यहाँ पे क्या हो रहा है कि ऑसिलेशंस लेस हो रहे हैं, लाइक very less oscillations we are getting. Hence, Hamming window is generally preferred over the Hamming window again. So these are what the points or concluding points we can say on this Hamming window. So we will stop it here. Further, I will take an example on these windows. Just put your attendance and we can leave. And please note down this theoretical part also so that you can remember the things. So this is all about like what are the different windows as per your syllabus. Like we have discussed down rectangular window and Hamming window. But still there are some other windows are there which is not required for you. And maybe in next lecture we will just have a comparison of all the windows. Then we will start with the example of these windows. And one announcement, on Monday I'm going to take ISC 2. Hello? Are you all there still?
Yes, sir. Yes, sir. No, sir.
Monday I'm going to take on Monday I'm going to take ISC 2. ISC 1, which chapter we have taken? I think first and second chapter, na? Hello?
Yes, sir.
ISC 1 फर्स्ट एंड सेकंड चैप्टर पे लिए थे हमने शायद, या थर्ड चैप्टर पे था?
First and second.
कौन सा था? फर्स्ट एंड सेकंड ना. So now I will take ISC 2 on chapter 4 and 5. नहीं तो 4 पे ले लेते, like I will take it on only 4th. Let's see. ठीक है. Chapter 5 अभी I need to cover some examples and all. So your syllabus for ISC 2 will be chapter 4. Is that okay? Hello?
Okay, sir.
Okay, right. Thank you. I'm going to close the session now.